All right, Earth Science students, so in the last video we talked about our different weather variables, and today we're going to be talking about how we can represent those variables on a weather map. So in front of you is a key to weather map symbols. This can be found in your reference table on page 14. And it kind of explains how we use these symbols right here, these weather station models, to show our different weather variables. Now, the important thing to remember about these map symbols, or these station models, is that where the number is in relationship to the station model determines what variable it's talking about. So for example, I've got 28 up here in the top left-hand corner. That is going to represent 28 degrees Fahrenheit. Temperature is always going to be up there in that top left-hand corner. Now, as a reminder, the whole thing that I'm going to show you right here is in your reference table, so you can follow along if you'd like. Down here in the bottom left-hand corner is our dew point. That's going to show us our dew point in degrees Fahrenheit. Now remember, the closer our temperature and our dew point are to each other, the more humid, or the higher the relative humidity is going to be. In between those two, we are going to see our visibility. So this is how far you can see. It looks like it's a half mile according to this particular station model. And that's going to be affected by precipitation, by haze, by fogginess, by any of those things that can affect our visibility. Next, we're going to look at this prong right here coming off of our station model. And that's going to tell us our wind speed and direction. So we are going to be looking at the direction that this is pointing in order to determine where the wind is coming from. So if you think about a compass where, north is up, south is down, west is to the left, and east is to the right, this prong is pointed in between south and west, which means that the wind is coming from the southwest and going towards the southeast. Remember, we name winds based on where they're coming from and not where they're going. Next, we have these prongs that are coming off here, these little flags or feathers, and they are determining, or they are telling us our wind speed. So a whole feather, that's this long one right here, is going to represent 10 knots, and a short one, or a half feather, is going to represent 5 knots. So you add those two together, and you get your total wind speed for the station model. So this is 10 plus 5, so this is going to equal 15 knots total. All right, next. The center circle is going to tell us approximately what our cloud cover is. So if we look at this, this is 3/4 of the way full, about 75% of our circle is covered. It's going to represent 75% cloud cover. So that's not an entirely overcast day. There's some bits of blue sticking out, but it's a mostly cloudy day, which makes sense because our temperature and our dew point are pretty close to each other, and that's going to represent, a more humid day. Present weather, that's this little thing right here. There is a key to it just below this chart that shows you what all those different symbols mean. This particular one is telling us that it is currently snowing. That's what the star is, that asterisk symbol represents snow. And we can look at our temperature, and it's 28 degrees, and it's pretty humid, so that makes sense that it would be snow. It's below the freezing temperature. Right up here, we got our barometric pressure. Now, this 196 does not represent our exact barometric pressure. It's not 196. It actually represents the number 1019.6 millibars. So that's going to be our actual pressure. They converted into this code just to kind of save some space, so that it's not taking up too much space on our station model. And I'm going to show you how to convert those on our next slide. The next one just below it is showing us our barometric trend. This says 19, and we've got something going up, a line going up. That means that it is rising, and we have this plus right here to also tell us that it's rising. So in order to figure this out, we're going to put a decimal point right between the 1 and the 9. It is rising 1.9 millibars in the past 3 hours. Oh, that got cut off a little bit, but that is in the past 3 hours. Finally, we've got our precipitation, and that is this number down here in the bottom right, and it's going to represent that we've got about 1/4 of an inch in the past 6 hours of snow, right? We know that it's snowing based on the present weather. We can also verify that that makes sense because it's below freezing, right? All of these numbers should make sense to each other. You shouldn't have a clear day with a present weather of rain, right? That wouldn't make sense in the real world. It wouldn't make sense in a station model either. All right, now let's take a look at that air pressure rule. let's take a look at how we decode the air pressure. So the basics to this is if the number is 500 or more, you're going to add a 9 in front of the number and a decimal before the last number. If that number is less than 500, you're going to add a 10 in front of the number and a decimal before the last number. So both times we're adding a decimal before the last number. That's going to be a step no matter what you're doing. It all just depends on what you're doing in front of the number based on what we have. So if we look right here, I've got the station model right here. It says 013 for Rochester. 013, that is a number that is going to be less than 500. So I'm going to add a 10 in front of that and then put my decimal point in the proper place. And I end up with a number of 1001.3 millibars. If I look at this other one right here in Albany, I've got 992. That number is greater than 500. And I'm going to add a 9 in front of that and add my decimal point to the proper place, and I get 999.2 as my millibars. Atlanta, same thing. Take a look at that first digit. It is greater than 5. It's greater than 500. So we are going to add a 9 in front of that and add our decimal point to the right spot. Last one over here, we got 026. What are we going to do? Look at that first number. It is less than 5. So I'm going to put a 10 in front of it and then add my decimal to the right spot. I get 1002.6. All right, let's take a look at some of the other variables that we find on here. So what is the air temperature for each of those 4 cities? So I'm going to be looking up at where the air temperature is supposed to be up here in the top left-hand corner, and I've got 70 for Rochester, 70 degrees Fahrenheit. If I take a look at the one for Albany, it says 77 degrees Fahrenheit for my temperature for Albany. Atlanta, 75 up in that top left-hand corner, it's going to be 75. And then finally Chicago, the coldest one on here, it's going to be 50 up in that top left-hand corner, and I've got 50 degrees Fahrenheit. So what is the wind speed and direction for each of these? So that's where I'm looking at this prong and these feathers coming off of it. So Rochester, if I think of north as being up, south as being down, west as left, and east as right, it looks like I've got this in the southeast. It's coming from the southeast. And I have one long feather on it, so that looks like my temperature is going to be 10 knots. Let's see, southeast and 10 knots. Perfect. All right, this one right here, it's going due south, and I've got 10 and a 5, so it's going to be 15 knots. So my direction is going to be south, and my wind speed is going to be 15 knots. Now, if I look at Atlanta, I've got in between west and south, so it's going to be southwest, and I've got 2 long feathers. That's going to be 10 and 10, so that means 20 knots total. And I get southwest at 20 knots. Finally, Chicago. It's just slightly west to north, and it looks like I got 1 feather. So let's see, it's pretty much due north. We're not going to take that into account. And we've got 10 knots as our wind speed. So we've got wind coming out of the north at 10 knots. When it's that close, you can kind of estimate and say that it's coming from. All right, let's do this together. Let's take a look at this one. So what I want you to do is I want you to pause the video here, and I want you to try and figure out all of this, and then I'm going to show you right at the end. So pause the video. All right, so my wind direction, it looks like it's coming from the north. We got this pointing at the north. My wind speed, we got 2 feathers, so I'm going to go 10 and 10. It's going to be 20 knots. Cloud cover. 3/4 of this is full. We could count each one of these as 25%, so we're going to go 75%. My air pressure, 092, so that is below 500, so I'm going to add a 10 and put my decimal point in the right spot. We get 1009.2. My barometric trend, it looks like it's increasing by 7.5. So I'm going to take a look at my previous one, 1009.2, and I'm going to figure out what the pressure was 3 hours ago. So 7.5 millibars and rising. So how do I do that? I got to do some math. Take the air pressure out of the code. That's what we did up here, 1009.2. And then I'm going to do the opposite of the barometric trend. So if it was rising, that means that it was less 3 hours ago. So I'm going to subtract the 7.5 from the 1009.2, and I get 1001.7. So that's what my air pressure was 3 hours ago. All right, wind direction. All right, I want you to try this one again, then I'm going to put up the answers in a minute. All right, so wind direction. Southeast at 25, Precipitation, we got 0.5, that's down here. Cloud cover 100%. Air pressure 1002.1. Barometric trend, so it was 2.5 and falling. It's going down, you can see right there, and the negative. So it means we're going to add that instead of subtract it to 1002.1, and we get 1004.6 as our air pressure 3 hours ago. All right, so that does it for station models. These are fairly simple, but it really pays to kind of take a look at the reference table and actually see where the different values are supposed to be, and kind of trying to memorize that a little bit so that when you see one of these on the Regents exam, they're not a total surprise. All right, on to the next video.